Like reciprocal. Okay, so if I said that I gave you the point 1, 2, what would be its inverse?
2, 1.
2, 1. It's as simple as that, right? You just switch the x and the y. But before we can talk about inverse functions, we have to talk about what's called a one-to-one function. So for something to be a one-to-one function, each x value is going to correspond to only one y value. Well, that's what makes it a function. That's the definition of a function right there. So that is not necessarily particular to just a one-to-one function. The second part of this definition is what makes something become a one-to-one function. So we have each value corresponding to only one y value. Then each y value can only correspond to only one x value. So if you remember back in the day, if I gave you a table of values, that would not be a function. Why not? Right, because one has pairings with two other numbers. So one's paired up with 2, one's paired up with 3, one's paired up with 4. That would not be a function. If I were to flip this and say 2, 1, 3, 1, 4, 1, that would be a function because every value of x is paired with only one y. So this would be a function, but this would not be a one-to-one function because it's not working in reverse with the y's. Okay? So remember the definition of just being a function. Only one x can be paired with one y, but for it to be one-to-one, it has to work in the reverse. So all your y's need to be paired up with just one x value. Okay? So let's go ahead. Let's skip this for a second. Let's do this really quickly. Let's first decide if we have a one-to-one function. Here's our set of numbers. It's function f. We have -2, 1, -1, 0, 0, 1, 1, 2, bless you, 2, 2. First, is it a function? Yes, because I don't have multiple x values, so that's okay. Is it a one-to-one function? No. Where do I have multiple y's? 1 and 1, right here. -2 and 1. So these points right here, let me highlight them. So -2, 1, 0, 1. That's making it not be one-to-one. Also, we have 2, 2, and 1, 2, which is keeping it from being one-to-one. Okay? So decide whether it is a one-to-one function. Not one-to-one. If you just want to do that for being lazy, go for it. So it's not a one-to-one function. Let's look at one that is. So part B. Here's function g. We have the set of the numbers 3, 1, 0, 2, 2, 3, 4, 0. So we're first deciding whether it is a function. I don't have any repeated x's, so we're good. Do I have any repeated y's? Nope. So this is one-to-one. So yes, one-to-one. All right, so if I want to do the inverse of this function, so g inverse, we use this little notation here to stand for inverse. Do not think of that as an exponent of -1. So don't turn that into 1 over g. That's standing for the inverse. So if I had the point 3, 1, the inverse of 3, 1 would be 1, 3. If I had the point 0, 2, the inverse would be 2, 0. And then 3, 2. And then 0, 4. So what should be true if my function is 1 to 1? Does its inverse stay a function? Yes. In that last problem, if I would have found the inverse, would it have stayed a function? No, because we had two separate ordered pairs that had double y's, right? So if I would have flipped them, then my x's would have had repeats in them. Bless you. So for something to be 1 to 1, that means, doesn't matter if you do the inverse of it, it's still going to stay a function. Okay? What is the domain of the original function? Which values represent your domain? The x. So in the original function, my domain was the set of numbers of, let's go smallest to largest. So 0, 2, 3, 4. And my range would have been 0, 1, 2, 3. In my new function, the inverse of it, what is your domain? 0, right, so it's just going to be your range of the first. So 0, 1, 2, 3. And your range would be the domain of the original, which would be 0, 2, 3, 4. Okay? So does that make sense for 1 to 1? So for it to be 1 to 1, it needs to be a function in both the original and its inverse. So you can't have double x's and double y's. Don't confuse it with just being a function. Functions, you're just worried about the x. For it to be a specific function, a 1 to 1 function, then it can't work both ways. All right. So what we can use is the horizontal line test to determine whether a function is 1 to 1. We've used horizontal line tests before to determine whether something has an inverse or not. I guess we used the vertical line test. So the horizontal line test, if something is a 1 to 1 function, then every horizontal line is going to intersect the graph at most once. Okay, so horizontal line test. A function is 1 to 1 if every horizontal line intersects the graph of the function at most once. So as opposed to the vertical line test, don't put this in your notes, just watch. If this was my graph, does that graph pass the vertical line test? Remember, a vertical line test was to determine whether something is a function, so that would be a function. Would that be a function? No, because it does not pass the vertical line test. Well, now what we're going to do for the horizontal line test to determine whether something is 1 to 1, so let's make a quick graph here. Nice little curve there. If I were to make as many horizontal lines as I wanted, do any of these horizontal lines intersect my graph more than once? Yes. Here it intersects twice. Here it intersects, well, I guess it would intersect 3 times if I continued it all the way through. So because this does not pass the horizontal line test, it's not going to be a 1 to 1 function. That's what I'm determining, whether it's 1 to 1, which makes sense because here I have repeat y values. So if I were to take the inverse of it, I would have repeat x values. So this one's not 1 to 1. Let's do one that is. What do you think it would look like if it was a 1 to 1 function? Yeah, just a linear line. So if we made this as our graph, would that pass the horizontal line test? Yes. So there it only intersects only one spot each time. So yes, 1 to 1. Okay. So given a set of ordered pairs, hopefully we can decide whether a function has a 1 that is a 1 to 1 function. If it is, you should be able to find its inverse. given a graph, we should be able to decide whether something is 1 to 1. Yeah? Got those two things down? Pretty easy? Okay, good. All right, so now let's actually write inverses of equations. This is the last thing you're going to have to do. So to find the equation of the inverse, just like we were doing with the set of ordered pairs, all we're going to do in the actual equation itself is interchange your x and your y. So where you see a y, you're going to turn it into an x. Where you see an x, you're going to turn it into a y. Then you're going to solve your equation for y. And then the last step is to bring in that inverse notation, which everyone always forgets to do this. You need to show that it is the inverse. And this is our notation that we're going to use for the inverse. So if it's in function notation, we say f of x to the negative 1. So that just is standing for inverse. It's not standing for 1 over f of x. It's not an exponent. If it's just a y equals, you can just do a y to the negative 1. It depends on the notation that they're giving you. So whether it's in equation form or whether it's in function form, you should denote it with your inverse notation. Okay? All right, let's do some inverses of each other. Here we go. Here we have f of x is equal to 2x plus 5. So I see an x. I do not see a y. What up here represents the y? Yeah, the f of x. So I'm going to rewrite this whole thing as y equals 2x plus 5. Now I'm going to interchange the x and the y. So the y is going to become an x. My x is going to become a y. So now my equation becomes x equals 2y plus 5. Can we solve this equation for y? Yes. What would you do first? Subtract the 5. Then we would divide by 2. I'm going to separate this into two different fractions. So I get 1/2 x minus 5/2 is equal to y. If I want to show that it's the inverse, and since I was originally in function notation, I'm going to take it back to function notation. So the inverse of f of x, it's a bad looking 1 right there, equals 1/2 x minus 5/2. There it be. Well, I guess we should decide if it was a 1 to 1. Is it a 1 to 1? Yeah, it is, because that's a linear graph, right? Questions with that one? All right. How about this one? F of x is equal to x minus 2 to the 3rd power. How do I know? I was going to say bless you. How do we know if it's 1 to 1? Make sure I'm doing this right. Well, let's think about a cubic graph. If I were to plug in 1 for x, so that would get me what? 1 minus 2 is negative 1. Negative 1 to the 3rd power is negative 1. Okay? If I were to plug in 1 again, would I get a different output? No. It's always going to be negative 1 when I input 1. So that's okay with my x range. Now let's think about the output way. Is there any other way for me to get a negative 1 on the output? Like if I plug in 3 minus 2 gets me positive 1. 1 to the 3rd power is positive 1. So is there any way for me to get a negative 1 inside my parentheses without putting in just 1? No. So since I can't get it any other way, it is going to be 1 to 1. Your key feature that you're looking for is whether this is an even exponent. Because if this was squared, then I would be able to get more than one output, right? If this was to the 4th power or to the 6th power. then I would have that parabola, which would not pass the horizontal line test. Does that make sense? Okay, so because it's an odd exponent, we're good to go. So now let's find the inverse of it. So I'm just going to jump right into making that an x, making my x a y to the third power. All right, how do we do a third power? Cube root. Good. Let's take the cube root of both sides. So now I get the cube root of x. I do not need a plus or minus there because I'm taking the actual cube root and not square root. Equals y minus 2. What's next? Add 2. So then we get y is equal to the cube root of x plus 2. Because we were in function notation, I'm going to take my inverse 2 function notation. F to the negative 1x is equal to the cube root of x. I'm running out of space. Make sure that plus 2 is not underneath the radical sign. Plus 2. It's on the outside. There will be our inverse. Okay. Now there is a test that you can use to show that it is correct and they are the inverses of each other. Do you remember doing our compositions of functions? Remember the f of f to the negative 1, that stuff? Remember doing that? So if I were to put my inverse function back into the original function, it should end up equaling it out to x when I get there at the end. Okay, I don't think you're going to have to do this, but this is just something that's good to know if you want it to check your answer. No. So if I plug this in to the x, I have the cube root of x plus 2 minus 2 to the third power. Well, what happens to the 2's? They cancel. What's the cube root of x cubed? Yeah. So because it's just equal to x, I know I did it correctly. I'm sure if we would have done that with the last one, we would have gotten there too. Okay? All right. So now can we step up our game, go back to that last inverse that we had, and graph both the original and its inverse? So let's make a quick rough sketch of a graph next to that problem. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Where would I start? 1, 5. My y-intercept. My slope tells me to do what? Up 2 over 1. Or if I didn't want to make more lines, I could go down 2 to the left 1. Down 2 to the left 1. Okay, so if this point is at 0, 5, where would its inverse be located at? Yeah, so if I plot 5, 0, my inverse of that point is going to be here.
You went down 1 on that one. The first one you did.
Oh, sorry, thanks.
I thought it matters.
Oops, come back to black. So down 2 over 1, down 2 over 1. Yeah, that looks better. What's the ordered pair of this point? Well, negative 1, 3. So the inverse would be 3, negative 1. So we can plot that, 3, negative 1. And then this point's at what? Negative 2, 1? So that would be 1, negative 2. There would be our inverse. Does that look like our graph? Was our y-intercept at negative 5/2 on that one? And then it was up 1 over 2.
That's a curve.
Yeah?
Wait, I did that too. What is wrong with me?
Let's do the cubic one. Let's just make a quick rough sketch of this guy. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, does anybody know what that looks like off the top of their head? It is going to be an SE one. Let's plug in -1. If I plug in -1, what do we get?
Negative one. Guru, -1, right?
Well, -1 minus 2 is -3 to the third power is -9. I don't have enough space there, so I'm going to go over. Huh? -27, that's right, to the third power. So I'm going to ignore that. How about 0? It would be -2 to the third, which would be -8. So I'm getting a little bit closer. I guess I could squeeze -8 in there. I need to add some extra lines.
Just go by two. Do two.
Here, look, I just put them in there.
You smell it now, or does it look like
Something's burning. So what do we say? 0, -8? 0, -8. What if I plug in +1?
Yeah. -1.
I'm going to get -1, right? -1 to the third power is -1. So 1, -1.
Can we go find a who's put in?
I can take a guess that it's Mrs. Sedler's classroom. 2 minus 2 is
Make it something biology.
0. 0 to the third power is 0. 3 minus 2 is 1. 1 to the third is 1. 4 minus 2 is 2. 2 to the third is 8. So I'm going to put that up there somewhere. Alright, so there's our graph. Notice it does pass the horizontal line test. So now let's do the inverse. What would be the inverse of 0, -8? 8, -8, 0. 6, 7, 8. What would be the inverse of 1, -1? -1, 1. What would be the inverse of 2, 0? 0, 2. What would be the inverse of 3, 1? 1, 3. What would be the inverse of 4, 8? 8, 4. 1, 2, 3, 4, 5. 8, 4 is right about here, let's say. So there would be your inverse function. Okay. Does the inverse also pass the horizontal line test? Yeah, so it would be 1, 1. Question?
Which one would what power would the one be like the upside down that one that does not
It would be an even exponent.
should be like probably like a 4?
Yeah, or squared. Probably not going to give anything higher than a 4 for that.
they're like a
Okay?
cylinder.
Think you got it? All right, I'm going to give you the rest of class to get working on your homework.